My name is Ethan Stanley, and this is Lab 1, Constant Velocity. Okay, in this experiment, I analyzed the motion of a ball moving with constant velocity. The objective was to use Virtual Python to simulate the motion and compare the experimental data using our theoretical expectations based on Newton's laws of motion. The experiment involved tracking the ball's position over time and used numerical methods to compute velocity and acceleration. The goal of this lab was to observe and analyze the motion of an object under constant velocity conditions. Using VPython, we modeled the motion of the ball based on experimental data and applied Newton's second law to verify the accuracy of these predictions that we made. This allowed us to explore how forces, velocity, and acceleration interact in a real-world scenario. Okay, so this was our experimental setup. We applied a force using our hand, and we watched the ball roll, as you saw in the video before, and its motion was tracked using time and its position. We then took the video and used the tracker app given to us by our lab TAs, where it measured the position at different intervals of time. The key parameters that we used in this experiment were the mass of the ball, which was 0.2 kilograms, the initial velocity, which is 0.196 meters per second, the net force, which was 0.847 newtons, and the time steps, which was 0.067 seconds, basically our delta t. This data was then incorporated into Python to simulate our motion over time. So to simulate the motion, I used VPython and applied Newton's second law. The following key equations were implemented into the code. The momentum principle, force equals mass times acceleration, which I used to update the velocity using the velocity update formula. Final velocity equals initial velocity plus force over mass times the change in time. And then using that, we plugged in the final velocity into the position update formula to find the next frame of position, or the next position in the next time frame, using those time steps that we had discussed previously before using this equation. X sub final equals X sub initial plus velocity times the change in time. And here's my VPython code that I used. And moving on. Okay, so these are our results and observations, or my results and observations that I made after I did this. Using my experimental data from the tracker and VPython simulation, I generated the position and velocity versus time graphs. The results showed that the ball moved with approximately constant velocity as expected. The velocity remained close to 0.196 meters per second initially, but changed slightly due to the applied force. The acceleration, calculated as 4.235 meters per second squared, was small, but consistent with our force calculations. The VPython simulation effectively matched the experimental trajectory, validating our model. So some sources of error that we could find, that I could find within the project, was experimental uncertainty. Obviously, if the video was deformed, or the ball was, the floor was incorrect, then it would obviously produce some sort of error within our laboratory results. And you can read the conclusion. This lab demonstrated the principles of constant velocity motion and Newton's second law. After comparing my experimental data with VPython simulation, we confirmed that our calculated values for the velocity and force were consistent with theoretical predictions. Thank you very much.